Hi, we are Group 14, and we're going to be giving our presentation today about the association between annual income and the relationship it has between the variables that make up credit scores. Our group is Daniel Brady, Henry Chen, me, Tejas Das, and Joe Klug. So some background info on our question. Again, are there any explanatory variables used to determine credit scores that are useful in predicting an individual's annual income? So for a brief literature review, a 2018 paper from the Board of Governors of the Federal Reserve System discussed the correlation between income and credit scores, indicating that credit scores and household income are moderately correlated. And then we have later, even this year, as a couple months ago, another 2022 paper found that for small businesses, so not even households, but for small businesses, higher credit scores themselves can increase income by more than 10% over the next 5 years. And so there's a pretty solid amount of information at this point. There are obviously many more papers that indicate that credit scores themselves can have a strong impact on income over time. But our research is more interested in whether or not the factors that affect credit scores can also affect income. So we have a couple of components here, like you know, uh, payment history that composes 35%, 30% debt, 15% length of credit score, 10% type of accounts and loans, and 10% recent credit activity. And so here we have our full model. Our full model is, we have five explanatory variables. And so we have for Y, our Y variable is annual income measured in dollars, that's continuous. Our beta 1 is outstanding debt measured in dollars, that's also continuous. Our beta 2 is credit utilization ratio, which is calculated as the sum of all balances divided by the total credit card limit. That's also continuous. Amount invested monthly in dollars is continuous, that's our beta 3. Our beta 4 is the credit balance measured in dollars. Our beta 5 is the credit score categorized as poor, standard, or good. That is our categorical variables. And so we have our five explanatory variables plus our sixth being our Y variable. And we have 100,000 observations according to R. And so this is what we're going to be using to do our research. And so for a bit of overview on the kind of non-transformed full model that we're using, you can see there's a lot of issues with it, and we'll be going over the remedies we use for that. For example, it's a very non-normal QQ plot. It's very curved, as you can tell. It's fairly heteroscedastic according to the scale location in the residuals versus fitted plots. And we can see in Cook's distance that even though there's not necessarily any influential points from that we can see, there's probably going to be some outliers, as you can tell, because of the way the points are distributed along that. So
All right, so now I'm going to talk about our research question 1, which is, do outstanding debt and credit utilization ratio have a significant impact on annual income? Here's the variable descriptions for research question 1, where all three of the variables are quantitatives. And in the following slides, annual income will be equal to Y outstanding debts. It's going to be X1, and credit utilization ratio is going to be X2. So first, look at our preliminary analysis. We have the basic equation of Y equals to 27,000 minus 8 X1 plus 1,097 X2. And as you can see on the right side, the residuals versus fitted plot shows a violation of constant variance. And the normal QQ plot shows a violation of normal residuals. As you can see, the left and the right tails is away from the center. And we also have a correlation of negative 0.075 between the variable x1 and x2, which means that there's no multicollinearity issue. So our remedial action here will be Box-Cox transformation. So first of all, we calculate the Box-Cox transformation with the lambda value equal to 0.03. And after the transformation, we got the multiple R squared value equal to 0.09332. And the F is equal to 2,573. And the residual versus fitted plot shows that the problem still exists, but slightly improved. And also the normal QQ plot shows that the normal residual problem is still not being fixed. So we continue on our another action, which is WLS. And now we compared our LLS output with the WLS output. We can see that the R squared value improves from 0.0938 to 0.1028. And the F statistics increases from 2,589 to 2,866. So now we have our final equation, which is equal to y equal to 965.84 plus 0.097 x1 plus 29.10 x2. And our adjusted R squared value improves from 0.0938, which is from our basic equation, to 0.1028, which is after we did the WLS method. And our standard deviation, which is the square root of MSE, improves from 36,000 to 1.225. And the ANOVA F test shows that the beta 1, the p-value of beta 1 and the p-value of beta 2 is all smaller than 2.2 times the 10 to the negative 16. So the conclusion for our research question 1 is that we reject the null, and the outstanding debt and credit utilization ratio have a significant linear impact on annual income.
So our second research question dives into do the monthly amount invested and the credit balance have a significant difference in linear impact on an individual salary? And you can see that as our hypotheses are, our null hypothesis is B3 equals B0, and our alternative hypothesis is B3 does not equal B4. So here are variable descriptions. Annual income was already talked about. That would be our predictor variable. And then our two explanatory variables are monthly amount invested and credit balance. So the amount of money invested monthly by an individual and the monthly credit balance for an individual. They range from $0 to $434.01 to $1,180, with a mean of 55.10 and 393, and they are both quantitative variables. So looking into our remedial analysis, our base equation is seen on that first bullet point. Looking at the correlation matrix, we see little multicollinearity between the explanatory variables, so that doesn't seem to be a major issue. But there are some irregularities with the residuals versus fitted plot, as well as a normal QQ plot. So that's going to lead us to our remedial action, which is going to be adjust the model to address the abnormalities in the residuals. So to address these abnormalities and build our model, decided to go from OLS to WLS. So we performed WLS and saw significant improvement in our model because our squared, adjusted R squared improved from 0.73 to 0.80 when using WLS. And then you can see below our 95% confidence interval for monthly amount invested and credit balance for those betas respectively using bootstrapping. Also to note, K-fold validation was used to help build our final model, and that yielded the final model equation of P0 plus 25,186 x3 plus 15,927 x4. So finally, for hypothesis conclusions, our partial R squared value for each predictor was 27% for credit balance and 50% for monthly amount invested. So these results are pretty significant. So we can conclude that what these values exactly mean is that when monthly amount invested was added to the model containing credit balance, the existing error sum of squares is reduced by 50% compared when credit balance is added. It is only reduced by 27%. So this significant difference in values, as well as the ANOVA test performed, lead us to reject the null hypothesis. And we have significant evidence that the monthly amount invested has a larger linear impact than the credit balance and is a much better predictor in the model.
In our third and final research question, we wondered if given a poor credit score, does the credit utilization ratio and monthly balance have a significantly different impact on annual income? So looking at these variables, they're the same variables as before, so I'm not going to dive too deep into them, except for the credit score. The credit score is grouped into good, standard, and poor categories. It's a categorical variable, and we modified this slightly to just be poor, and then good and standard were a second category. So for our model building, our basic model, we used a MLR with B2 or beta 2, beta 4, and beta 5, and then we also used beta 2.5 and beta 4.5 to test whether there was a significant linear impact of beta 5 on beta 4 and beta 2, and then where x5 is 0 if credit score is good and 1 otherwise. And then using the residuals versus fitted plot of this model, we can see that there's a violation of the constant variance of the residuals, and using the normal QQ plot, we can see that there's a violation of the normality of the residuals. But at least with a correlation of 0.22 between x2 and x4, multicollinearity is not an issue. So our first diagnosis was to transform y. Transforming y using a Cox plot did not alleviate the issues with the constant variance of the residuals. Instead, a chosen value of lambda equals 2 was used, and there are still issues with the variance and the normality of the residuals, but it's definitely a lot better. So the next step was to use WLS to transform again. With WLS, our residual issues are mostly resolved with a mild normality issue. However, with WLS, the R squared value of the model was significantly decreased. Testing the hypothesis. Our hypothesis was that beta 2.5 and beta 4.5 were both equal to 0. Our alternative hypothesis was just not that. Using a 95% confidence interval bootstrap to determine beta 2.5 and beta 4.5, and then back transforming them with, we find that beta 2.5 is between 29,000 and 40,000, and beta 4.5 is between -5,000 and -1,600. And so With this 95% confidence level, we find that there's a significant impact on the linear effect of both credit utilization ratio and monthly balance have on annual income when your credit score is poor. Building on that, we also did a k-fold cross validation to validate our model, getting a similar R-squared result of 0.31, which isn't great, but we still have significant enough results to come to a conclusion and reject the null hypothesis. Talk faster.